Hey everybody, Dr. A here, and in this video we're going to be exploring an example of how to calculate the centroid of a composite area. So before we get started, just a reminder, a composite area in statics and physics is one that deals with an area that has multiple different shapes making up its entirety. So in this particular example, we have this L shape. So it's made of two simple shapes. Obviously, it's made of two smaller, simpler rectangles, okay? Now, whenever we deal with a composite area, we can always separate the different area segments into their smaller, simpler areas, and we usually have some options for this, okay? So in this given example, we're being asked to compute the coordinates of the centroid for the shape. So if we look at this L shape, we can see that we could separate this area, this L-shaped area right here, where we have a 10-inch long by 3-inch wide rectangle, and then we have a 12-inch long by 3-inch tall second rectangle, or we could split it at this interface where we have a 15-inch by 3-inch bottom rectangle, and then a 7-inch by 3-inch upper rectangle. So again, it doesn't matter how you separate this. If you want to separate it like this or like this into the two rectangular areas, it's whatever you prefer, okay? So I'm just going to separate it the first way I drew this. I'm going to put a little separation right here, and I'm going to use a different color just to help me visualize this. And once you have separated this, you want to label, this is just for labeling purposes, you want to label each part so you can help keep track of things. So I'm going to call this part 1, and I'm going to call this more horizontal rectangle part 2, okay? The next thing you want to take note of is an origin or datum. Now, in this particular example, we were not given an origin. So under solution, I'm going to make a comment here. I'm going to say when an origin or datum, a datum is just a reference axis, is not provided, you define your own, okay? So since one is not provided, I'm going to define my origin in this bottom left corner. If you ever have to define your own origin, you want to define it in a very convenient spot that makes your calculations basically less miserable. So I'm going to call this my y-axis, and I'm going to call this my x-axis, and again, this bottom left corner is my origin, okay? Now, how do we calculate the centroid? Well, we have a couple of handy formulas. So remember, a centroid is a set of coordinates that we typically call x bar comma y bar, okay? So x bar is going to be given as the summation as I goes from 1 to n of x sub I times a sub I. And we're going to divide that by the sum of all of the area pieces, a sub I, as I goes from 1 to n, okay? And so if we expand this for our problem, how many parts do we have? Well, we have 2 parts. So we're going to go from 1 to 2, okay? Our n value is going to be 2. So for us, we can rewrite this as the sum I goes from 1 to 2, x sub I, a sub I, divided by the summation I goes from 1 to 2 of a sub I. And again, this is just being mathematically proper. If I expand this, that's x1 a1 plus x2 a2, all divided by a1 plus a2, okay? Similarly, y bar is going to be the summation as I goes from 1 to n of y sub I, a sub I, all divided by summation as I goes from 1 to n of a sub I. And for our problem, again, we have 2 parts, so I'm going to expand that to y1 a1 plus y2 a2, all divided by a1 plus a2. So basically, the work we got to do is to get all of these different values, okay? So let's go one piece at a time. So I'm going to start with part 1, okay? My part 1 was this rectangle right here, okay? So what is A1? Well, A1 is 10 inches by 3 inches. So A1 is going to equal 30 inches squared. What about X1? Well, X1 is going to be my horizontal distance to the centroid of part 1 measured from the origin, okay? So my centroid of part 1 is going to be right smack dab in the middle of part 1. Well, what's this horizontal distance right here? Well, I'm going to maybe pause the video if you want to think about it, but I'm about to tell you, it's half of 3, okay? So that's going to be 1.5 inches for X1. So just to color coordinate, my X1 value is 1.5 inches. What about Y1? Well, again, Y1 is this height right here, okay? So my Y1 is going to be the distance from the origin up to the centroid of part 1, okay, which is half of 10. So that's going to be 5 inches. So I'm going to say here Y1 is 5 inches. What about part 2? So looking at part 2, we separated part 2 out as this rectangle, which if you notice is 12 inches by 3 inches. So the area of part 2 is 12 times 3 is 36 square inches. What about X2? Well, again, X2 is the distance from the origin to the centroid of part 2. This is X2 right here. So if you say X2 is 6 inches, you're actually going to be wrong, okay? That's a good wrong answer, but that's still wrong. Remember, X2 is measured from the origin to the centroid of part 2. So what is this distance here? Well, it's 6 inches plus this other 3 inches, okay? So it's actually, X2 is actually 9 inches, all right? And what about Y2? Well, Y2 is the vertical distance from the centroid up to, I'm sorry, the origin up to the centroid of part 2. So Y2 is this distance right here, Y2. So that's half of 3 inches, which is 1.5 inches, okay? So now that we have all of these pieces, we are ready to calculate our centroidal coordinates. So I'm going to say X bar is 30 inches square. Here, let's write the terms in the same order that we wrote them earlier. 1.5 inches times 30 inches squared plus X2 times A2, which is 9 inches times 36 inches squared, all divided by 30 inches squared plus 36 inches squared. So if I punch this in my calculator, I'm using my TI-36X Pro calculator to perform this operation. And I'm punching it in nice and slow so I don't accidentally make a mistake. I get 5.591 inches as my X bar value. And then I'm going to calculate Y bar. That's going to be 5 inches times 30 inches squared plus 1.5 inches times 36 inches squared, all divided by, of course, 30 inches squared plus 36 inches squared. So I'll punch this through. 5 times 30. Again, I'm doing this in my TI-36X Pro calculator. And I get 3.091 inches, okay? And so basically what this tells us is that our centroid is about 0.09. Our centroid is about right here, okay? That's x bar, comma, y bar. And it's okay that our centroid is outside of the area. Remember, the centroid it's very similar to a center of gravity or center of mass, except for an area we use the term centroid. Okay, so again, we go back to these basic governing equations. N is the number of parts in the composite shape that you're dealing with, and you just want to separate your composite shape into simpler shapes. In this case, we simplified it into two rectangles, and we referenced each part's centroid to a common origin, and we took that as the bottom left corner, and then we just went to town with our computations. So hopefully you found this video helpful. If you did, please hit like and subscribe and be on the lookout for more content like this. Thanks for watching.